Hello everyone, I'm Tom Anderson from the University of Sheffield in the United Kingdom, and I'm here to talk to you about transitions in university lab teaching in an age of pandemic. So first of all, a little bit about my background. I was one of the first groups of students to do A-levels, which are the university qualifying qualifications in England, um, with an exam both called AQA. But I was one of the first groups to do it after the government made a big change and the teachers were scrambling to respond to that change. So I know what that's like. Which our students have also been through. Um, I took my undergraduate degree in natural sciences at the University of Cambridge, followed by a PhD at the same institution, and then since 2012 I've been employed by the Department of Chemistry at the University of Sheffield. Now, in this career, there are two key transitions there. One from A level or other precursor studies to university, and then from university to employment. I'm focusing on that first transition because I teach our first year lab course. So any changes to how A levels are taught will impact or should impact on how I do my teaching. I took over our first year lab course straight after there had been a change to the A level, so students were coming in with a different experience to before. I was advised sort of don't bother changing anything yet because we were planning on changing our whole curriculum anyway. But I was a bit concerned about taking that attitude because there had been a big change to the A levels. That's the new AQA logo. They've changed it since I was doing my A levels. Notice the new there, and there is full information there. There's a link there if you're interested. But the upshot for what I was concerned was they had introduced a new practical endorsement by which students must do a minimum number of experiments, which was to stop sort of poorer and disadvantaged schools not having students doing an appropriate level of practical experience. And students must pass competencies in order to get this separate practical endorsement, which is separate to the exams. The experiments, there are some suggested experiments, and they often include recrystallization and titration. So pretty much any student you're going to get who's come out of the current English A levels will have done a recrystallization before, for example. So on taking over the course, I made a few immediate changes, but the main thing I did was to consult the students using a very useful program we've got at Sheffield called Student Observation of Teaching. I consulted the students on their response to how the course currently was and how to record their reaction to ideas I had for the following year. And I also got the graduate teaching assistants and lab teachers to give me their views on what it was like to teach these students. So the key findings they reported to me that the students did not know more chemistry theory, but they were a lot more confident in the lab. We didn't have the usual sort of stereotype of level one students sort of panicked holding a beaker of water in tongs because if it's in a chemistry lab it must be dangerous. They often have that attitude. But now with this additional practical experience they were able to judge hazards better, and that meant we could challenge them more. We didn't have to spoon feed them everything and really make them come out of their shells as usual. So therefore we had the opportunity to challenge them further. The students were also enthusiastic when I asked them about the idea of a more concise lab manual, and I'll talk about why that is later. The key principles I took for reform were to focus on resolving any outstanding problems with the course before innovating, and then this is the most important point I want to make in this talk. To gain student engagement and respect, students must have confidence in staff knowledge of their previous experiences. If you unknowingly reinvent the wheel, if you say, right, we're going to do this today, we're going to do a recrystallization, and talk to them as though they have no idea what it is and they've never done it before, students are going to feel patronized. They're going to feel that you don't know what their past experience was, and they're going to lose confidence in why should I invest my time in paying attention to this person and this course. This happened to me when I was at university because in the then new A levels I did, for example, we had introduced NMR. So I'd learned quite a bit about nuclear magnetic resonance spectroscopy. I then went to university, and my courses at university assumed nobody knew anything about NMR. And maybe they were just trying to be inclusive of people from non-A level backgrounds from other countries who maybe hadn't had the same opportunity. But my sort of impression was you've not updated in line with the new A levels. Therefore, I can't trust that what you were teaching me is worth me investing my time. And it just makes you overconfident and think you know it all already when it's one specific thing, and that will cost you in the long run. So I'm very keen to avoid this happening with our students. So therefore, if your students have an existing skill, acknowledge that they have it, make it clear that you know they have it, give them the opportunity to practice it, And if you do choose to repeat an exercise, make sure you explain why you're doing it. Like, yes, you've done a recrystallization before, but you need to practice. We're doing it with different equipment. We're teaching you a higher level of theory. All of these could be reasons why you still do that. And we still do teach them a recrystallization, but we don't pitch it as though this is the first time they've ever done it. So when we rolled out this new lab setup, I then conducted some anonymous Likert type surveys in semester 1 of that year, and you can see there's the form. That black bar just means I've missed out part of the consent form. But I asked them about 15 questions on a Likert scale, and then I got the findings, and I plan to follow this up with focus groups in semester 2. Unfortunately, this academic year was 2019 2020. So by the time we got towards the end of the lab course, when I was planning to do this, events happened, and therefore, fortunately, we nearly finished the lab course. So I was investing all my time in just putting together a few small online activities to try and finish off the lab course, but we were still scrambling to get online teaching to work. So this was not a time when I could think about trying to run the focus groups online. It was not a priority. So therefore, unfortunately, I've never had focus groups on the data I obtained. Now, we are teaching students again this academic year, and I'll talk about how we're doing that later. But I've done the same survey again with those students. That's incomplete so far. I will do the focus groups online with them, but it does mean that the data I'm about to show you is from students before the pandemic, just so you understand that, recorded in 2019. Okay. So here's an example of disconnect, another example of disconnect between teacher attitudes and student attitudes. Here's a very famous quote in pedagogy from Mark Prensky in 2001. The most useful definition I've found for them, i.e. students, is digital natives. Our students are all native speakers of the digital language of computers, video games, and the internet. That's the theory. Here's the practice. Here's something a student born in 2002, a year after Mark Prensky said that, said to me when we were doing an assignment. He said, I could use some more help with this. I've never really used a computer before. Now, that's an extreme case, but it's not an out there case. And this is not a student from a developing country, a student from a poor background. This is a student from an average UK socioeconomic background. So what's going on there? Well, the problem is that people have confused the fact that students have smartphones and are on social media, which is itself a stereotype, but you know what I mean, with the idea that they therefore know how to use computers and do, rigorous computer work. And in fact, a startling revelation to me was people of my generation have probably used computers more at school than the current generation of students. And the reason for that, as far as I can tell from talking to students, is that they've gone through life where everyone has always assumed they already know this. They sort of, at birth, they know how to code or whatever, and therefore teachers just assume, oh, you know how to do this, and they never tell them, again, broadly speaking. So this became very relevant in 2020 when everyone is assuming that students know how to do online learning. When in reality you're often having email exchanges of how are they going to scan in things and convert them to PDFs and send them to you, and fairly trivial things like that. This is not the students' fault, of course. They've just never been taught it because everyone assumed they just know. But it's an important revelation to understand. Don't judge students by stereotypes. And again, I actually asked the students, this is before 2020 again, do you agree with this description of you as digital natives? And 70% did agree, which sounds like a lot, but it means that 1 in 3 are not happy with this description. And I think a lot of them find it patronising or assuming information. So again, it's something to bear in mind. And I asked more specifically about 3 of the most important productivity software suites. Again, I've said specifically Microsoft here, but this could be the equivalent. And so there were a couple of interesting revelations here. Everyone tends to assume students know how to use Word, and that's largely true, as you can see here, at least to a certain basic level. There were 2 interesting discoveries here. One is we tend to assume students have not had much experience doing presentations with PowerPoint, but in fact what they told me informally, this, as I say, I was not able to do focus groups, but what they told me informally was actually that is emphasised a lot, and it has been emphasised at A level for a while now. So therefore, they do know how to use PowerPoint, and we shouldn't teach them as though they've never done that before. However, the converse is a lot of them have, a majority in fact, said they had very little experience or they were not confident using Excel. And that's a problem because it's often assumed they have done that before at A level. What a lot of students have told me is they never used Excel at A level, not at chemistry A level anyway, sometimes for maths or physics. And the result of that is you end up with a situation where you do have to go around a physical chemistry lab looking to make sure students are not doing all the sums by hand or with a calculator and then typing the answers into the spreadsheet, which sounds bizarre, but they've never been told what is a spreadsheet for and how to use it. So that is an important example of something we can't assume knowledge, but on the other hand, we shouldn't assume lack of knowledge with PowerPoint either. So that was a very interesting revelation there. This I find to be a more troubling matter. So I'm just presenting the results for a few of the questions here. For time reasons, but this one, we tend to assume students are scholars. I mean, the term sounds synonymous. A scholar being, someone who fundamentally learns through reading. But I asked the students, do you still read for pleasure? And you can see there's a control group there of television or streamed video media, because students often ask for help videos nowadays, and that's often a natural thing to turn to, tutorial videos on YouTube for everyday things rather than instructions. And what I found was, about 1 in 3 students disagreed with the idea that they read for pleasure, and I found that to be a problem, not just because what it says about the species as a whole, but fundamentally, if you have not grown up with the idea of, sitting down to read this for pleasure, I'm being topical with Andrea Camilleri there, but if you've not sat down to read that for pleasure, then when you see a book like that, you are not just going to see, oh, this looks like a big book. You're going to see, that's literally impossible. Nobody can possibly expect me to read that. Therefore, I'm just going to ignore it or read the smallest amount possible to answer one question and then stop, because I have no sort of stamina to read long pieces of text. And again, I am myself stereotyping a bit there, because I want to ask students more detail about this when I do focus groups, but that is a serious concern. If you have a setup where you expect students to do large amounts of reading and they have never done that before, that is going to be a lot more tiring and wearing to them than it would be for someone who grew up reading a lot like myself. So what's the best way to communicate information and maintain skills development continuously? So what I found was the big lab manuals I inherited from my predecessor were 270 pages per semester. And the main reason for that is everything was explained in a great deal of detail. Every time a student had asked a question, my predecessor had put the answer in there with the assumption that, the next student will see it there and then won't ask me the question. But the problem was, the bigger you make the book, the less likely you make it that the students will ever open it. So therefore it becomes pointless. And in fact, we ended up having to repeat things like safety and skills, which didn't change from year to year, but we had to repeat them every year because it was assumed, well, we can't expect the students to carry out another big book every year, and it was getting ridiculous. So I took the lab manuals and I cut them in half, basically. I was able to compress experiments down to much less by assuming more knowledge from the students from the new A-levels, and that worked well. And then I made a second manual, which is carried through year on year. The first one is just for a certain set of experiments, but so that's the thickness compared there. But I made a second manual, which I called a safety and techniques manual. And this is a short one, which just goes through all the techniques generically. They can always refer back to it year on year, and it has the safety information in one place, and they don't need it ever again, because it's the same safety every time. So I asked the students if they found this to be a good change. And although one year group doesn't have a basis for comparison, about 75% did agree this was a good thing. So I think I am appealing to the students, although again, it's worth having a focus group to how they understand this and do they understand what I was trying to do with it. So that's an interesting point, what has come from the feedback surveys, I say. Okay, or that has come, I should say. And the point is, by doing all this activity, I think it has become clear to the students that I care about making sure the course fits with their previous A-level knowledge. And you can see here, a majority of students do agree that the course is designed with that. Again, I want to speak to the students via focus groups, not me personally, but via focus group facilitators who don't agree with that, and what would they like to see that I've not taken into account from their A-level teaching. Now, one thing I've not talked about so far is the pandemic, which came in. We then had to think, what are we going to do for the next group of students coming in September 2020 or October 2020? And our decision was, you need to have practical in-person teaching in chemistry. Not everyone agrees. Some people have tried to do online equivalents, but we feel there is no equivalence. You have to have practical online, in-person, not online, in-person teaching. And suddenly we had an advantage, which is that there isn't a good photo of these online because we were always embarrassed about them. We've got these big, spacious, wooden, old-fashioned looking teaching labs. But you know what they are? As I said, spacious. If you look at the fume cupboards in the background there, you can put one student in each of those fume cupboards and they are more than 2 meters away from the next student, which means social distance lab teaching is possible. we were able to design a lab course based around that, using many more lab days because you could only get 18 students rather than 55 in safely at a time. But we've been able to carry out a full lab course, which we're currently halfway through, which I'm really proud of. We were able to achieve that. And that's the schedule from the student perspective there, just for information. So there are 4 lab days and then writing up. And this also meant that students who previously were doing work in pairs for some experiments could no longer do that. And what that meant was suddenly they had to act more independently. You know what has prepared them to act more independently? The new A-levels and the course which I had already designed to take those new A-levels into account. So this worked out relatively well, considering, although it took a lot of hard work from me and my technical staff in order to make these lab courses work. Alright, so I've run out of time, so I'm just going to shortly conclude. We must respond to changes in A-levels, and it also is an opportunity to challenge the students. These self-led learning and innovation stood us in good stead when students had to work more independently during the pandemic, and we can't reduce the students to stereotypes. As I've just said there, and that's just more or less repeating what I've just said, and it shows how important pedagogic research is. So in conclusion, thank you for listening. Sorry, I just went slightly over time, but I hope you enjoyed that. Goodbye.